Welcome back. So a quick history of knowledge graphs and knowledge representation in general. So in artificial intelligence, this is one of the subdisciplines, KR, knowledge representation, and it's as old as artificial intelligence itself. The general question is, how do you formalize knowledge? How do you represent knowledge in a system so that you can make use of it for an AI application? And here in this overview, you can see that obviously over the decades, people have tried out different representation formats. First, notice the different sides of the time scale here. So this is a split that has always been there between a side that works on these artificial neural networks and is sort of developed somewhat independently of the symbolic approaches. So that's the connectionist approach. And on the other side, we have the symbolic approach. So here, the concepts that we are using are appeared as early as the 1960s. So semantic networks and frames, they are more than 50, 60 years old. The essential ideas, for example, frames, they became the foundation for what you know as object-oriented programming. So again, object-oriented programming has its root in AI research, like so many other topics. And what we do here with knowledge graph is also not something that's brand new. This is something that people have thought about and worked on for decades. So what's sort of new is a technical standard for writing down these knowledge graphs. Before, people came up with obviously lots of different implementations, and they stayed mostly on a very small toy level. They weren't really meant for large-scale knowledge graphs, large-scale systems. So this is one of the big advantages that we have now. We're going to look at the standard RDF in the next section of the lecture. And obviously, we also have a lot more resources available. So very large databases on the web that we can use to build these knowledge graphs, which simply wasn't possible in terms of the scale 50 years ago. So what we are using now comes out of, again, an area of research that's called the semantic web. So in this initiative, people built a number of standards for making the World Wide Web machine readable. So the classical web that you all know and use, HTML, HTTP, and so on, that was meant for human users. And people very early thought about how could we use all of this information on the web for machines. But for machines, you need something that's machine readable. If you have a page and there is stuff in red and in bold and various other markup information, for a human, this gives you various information, but to a computer, this is really not very helpful. So similarly to markup for human users, people came up with markup for machines. And this is essentially what we are using here. So I mentioned also this semantic web as a research field in the very first lecture. So basically, these knowledge graphs are one area of the semantic web technologies. Basically, it's an application of AI onto the World Wide Web. Similarly to knowledge graphs, the idea of a personal digital assistant like Siri or the Google Assistant isn't something that is brand new. You've already seen Eliza. But okay, Eliza was sort of an experiment in building a chatbot. It wasn't really meant as a personal digital assistant that helps you in your day-to-day tasks. And a very nice vision that was developed by Apple was the Knowledge Navigator. So I'm not going to show you the video here. Same for a couple of other videos that I'm going to talk about during the lecture. I'll come back to it in a minute. And then before we go to the next lecture topic, you can just watch it yourself. It's like 5 minutes long. But when you watch it, you can see that the ideas that you find in an iPhone, and some of you might know before the iPhone, there was the Apple Newton device, which wasn't that successful. All of these technologies, they have their roots in much older work. And this was kind of a groundbreaking vision of how you could have such a personal digital assistant. And when you watch it, again, it's from 1987, think about what of this vision from back then is possible nowadays with a modern assistant and what is still a bit out in terms of technology. But just to summarize before you go and watch the video, what has happened in the 1950s, around the time AI started as a research field, the concepts that we're using now, semantic networks, reasoning formalisms like description logic, they were already developed and people thought about these. People worked with them in terms of AI applications in the 80s and 90s. And if you've taken an AI course, you have heard the term of the AI winter, meaning there were at least two major phases in AI where people sort of gave up. AI became overhyped. One phase was in the early phases in the 1960s, 70s. And then again, there was another phase in the 80s, 90s, where people just gave up on AI and said, well, nice ideas, but this is never going to work. Especially in the 80s and 90s, there were a class of systems called expert systems, and they relied on manual input of knowledge and rules. And if you did this manual input work, there were some systems that are successful for medical diagnosis and other tasks. Then they worked quite well, but people quickly realized building anything of this on scale for multiple domains just doesn't work. It's just way too much work. So this was termed the knowledge acquisition bottleneck, meaning in theory, people could build AI, but the main bottleneck was giving the AI all the knowledge that it needed to do a certain task. And that just didn't seem feasible. And again, there was a phase, an AI winter, where people just gave up and said, forget about it, this is not going to work. So what has changed over especially the last 20 years? On the technical side, we have open standards, especially for these knowledge graphs. They are based on a World Wide Web standard. So the W3C is the World Wide Web Consortium, which standardizes the web, HTML, HTTP, and so on. And there's also a standard related to this knowledge representation that we'll cover in the next lecture segment. And it was picked up by industry, so it's not just an academic exercise. This is something that's built into many products. And then finally, we don't just have the standard and an empty knowledge graph. We have content available. So we have large-scale knowledge bases. And they're available both in a proprietary way. Now, for example, Google has its knowledge graph, but it's not open source. You cannot download it anywhere. Similarly, Facebook has all the information about all the users and their connections in their own Facebook graph, but it's not publicly accessible. But there is a large number of open, publicly accessible knowledge graphs that you can use in an application. And we'll cover more of these in detail in a couple of weeks. We'll see a few of them before, but I'll talk about this whole set of publicly accessible knowledge graphs in 3 weeks. So now you know what a knowledge graph is. Knowledge represented in form of a graph. The main questions that we have to look at is how can we build a graph like this? Both conceptually, what do we put into the entities, into the attributes, into the edges, and also on the technical side, how do we implement this in the system. And this I will show you in the next lecture part. But before you go there, take a few minutes and have a look at this vision of the Knowledge Navigator. Apple actually made, I think, 3 videos like this, 2 or 3. So this isn't the only one, but start watching this one. And then I will see you in the next lecture part. Bye-bye.